Explorer 1, NASA's farthest traveling rocket, proceeds with its astonishing endeavor through space, perfectly imparting critical data from the deepest regions of the universe. For almost 50 years, this marvelous space probe has changed our understanding of space. However, the spacecraft has recently been transmitting unsettling data back to Earth, leaving the entire space industry in shock. Are these disturbing signals the result of a technical malfunction or the activities of extraterrestrials? Join us as we uncover the truth behind these captivating transmissions. Since the dawn of history, experts have been fascinated by the mysteries that lie beyond our celestial boundaries. This curiosity led to the historic launch of the Voyager 1 and Voyager 2 spacecraft, among other remarkable space missions. These groundbreaking missions, which had been planned for a long time, began with the launch of Voyager 2 from NASA's Kennedy Space Center on August 21, 1977. 14 days later, on September 5 of that same year, Voyager 1 followed. These twin probes, each weighing a substantial 720 kilograms, equivalent to a small car, were propelled into space during a unique alignment of the outer planets. Throughout their incredible journey, these bold explorers traveled in different directions and at different speeds, leading to a crucial moment on December 15, 1977, when Voyager 1 overtook its identical twin due to variations in their trajectories. Since then, Voyager 1 has become an invaluable asset, providing us with a wealth of information and unraveling space-related mysteries. The Jovian Imaging Mission. Before we dive into Voyager 1's shocking new discovery that stunned the entire space industry, let's take a look at the extraordinary images captured by the spacecraft during its crucial Jovian imaging mission in 1978. At that time, Voyager 1 was positioned about 265 million kilometers from Earth. From this vantage point, it transmitted a stunning number of photographs back to Earth. In January 1979, it embarked on an exceptional 100-hour endeavor, capturing a mesmerizing time-lapse film showing 10 rotations of Jupiter. A collection of 3,750 images allowed us to observe Jupiter's majestic dance in clear detail. In the following months, Voyager 1 navigated through the Jovian moon system, making a remarkable discovery: the presence of a faint ring surrounding Jupiter and 2 new moons, further expanding our understanding of this fascinating planet. To ensure a safe passage and avoid a potential collision with Titan, one of Saturn's moons, corrective maneuvers were executed. Voyager 1 continued its celestial journey around Saturn, revealing 4 additional moons: Mimas, Enceladus, Tethys, Dione, and Rhea. The end of the planetary mission. With the conclusion of the Saturn mission, scientists decided to end the Voyager planetary mission, sending both Voyager 1 and Voyager 2 beyond the boundaries of our solar system. Traveling through space at an astonishing speed of 325 million kilometers per year, Voyager 1 entered a new chapter in January 1990, the Voyager interstellar mission. During this phase, Voyager 1 captured some of the most famous photographs in history, immortalizing the Sun and most of the planets. One key figure in extending the missions beyond their initial objectives was the prominent astronomer Dr. Vasily Sands. As part of the Voyager imaging team, Dr. Sands strongly advocated for capturing one final set of images as a farewell gift to humanity. Against all odds, his unwavering determination paid off on February 14, 1990, when Voyager 1, positioned 6 billion kilometers from the Sun, embarked on a visual journey known as the Planetary Family Portrait. These breathtaking images, totaling 60, added to the probe's remarkable collection of 670 photographs taken during its encounter with Neptune. Record-breaking discoveries. Voyager 2 achieved an extraordinary milestone by recording wind speeds on Neptune exceeding 13,100 meters per second, the fastest winds ever documented in our solar system. As the spacecraft ventured within 280 million kilometers of Neptune's methane-rich atmosphere, it provided remarkable insights into this distant celestial body. Notably, Neptune's largest moon, Triton, was revealed to be one of the coldest objects in our solar system, with surface temperatures plunging to a frigid -391 degrees Fahrenheit. Triton's unusual features, such as its nitrogen gas-spewing ice volcanoes that propelled frozen particles 5 miles into its thin atmosphere, further captivated our imagination. These extraordinary discoveries expanded our knowledge of the vast diversity and complexity of celestial bodies residing in the outer reaches of our solar system. The terrifying new discovery. Don't go anywhere. Voyager 1 has recently made one of its most terrifying discoveries yet. First, let's review what it has achieved over the past 45 years. The accomplishments of the Voyager twin probes have been truly remarkable. Over 4 decades ago, Their initial observations of Jupiter and Saturn's moons astonished scientists and shattered previous assumptions about these distant worlds. Once thought to be dormant and heavily cratered like Earth's moon, these moons turned out to be teeming with geological activity. Voyager 2, in particular, achieved several extraordinary milestones during its journey. In 1986, it made history by becoming the first spacecraft to fly past Uranus. Just 3 years later, it achieved another exceptional feat with a flyby of Neptune. To this day, it remains the only spacecraft to have followed such a trajectory. As the Voyager probes continued their journey, NASA implemented various measures to extend their operational lifespan. Over recent years, unnecessary components and radiators have been deactivated to conserve energy, ensuring that these brave explorers can continue their mission well into the next decade. Their estimated mission end date is set for 2030. For the scientists and engineers who have been involved in this extraordinary project from the beginning, the pinnacle of the Voyager missions is both a moment of pride and a touch of melancholy. Their unwavering dedication and passionate efforts have far exceeded their initial expectations. The wealth of data returned by the Voyagers has provided invaluable insights, fueled numerous scientific discoveries, and ignited the imagination of countless researchers and space enthusiasts. Voyager 1's unsettling transmission. Voyager 1 and Voyager 2 were no ordinary space probes. They were meticulously designed with a spin rate over 15 times slower than the hour hand of a clock. This design choice minimized visual blurring as the spacecraft captured images and data while moving through the vastness of space. Even before their encounters with the outer planets, their impressive imaging capabilities began to astonish scientists and the public alike. The spacecraft began transmitting images of Jupiter before even reaching the gas giant. These early images, showcasing the swirling clouds and the iconic Great Red Spot, captivated audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly stole the spotlight. Io, slightly larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The spacecraft's instruments detected unusual signals from Io, which were confirmed by the striking images they captured, towering volcanic plumes and a surface scarred by eruptions. One of Io's most prominent volcanoes erupted with a force over 100 times greater than Mount St. Helens, covering an area nearly the size of France. While the spacecraft's cameras were eventually shut down to conserve power and memory for their journey into interstellar space, it is important to note that the images they captured did not include Mercury and Mars for various reasons. The road ahead. Besides the Voyager 1 and Voyager 2 interstellar probes, NASA has also launched other notable spacecraft, such as Pioneer 10, Pioneer 11, and New Horizons. Voyager 1 passed by Pioneer 10 on February 17, 1998, marking the moment when Pioneer 10 became the most distant spacecraft. Voyager 1 continued its solitary journey for 14 more years before finally entering interstellar space on August 25, 2012. Although there were no other spacecraft present to witness this milestone, NASA did not publicly announce this remarkable achievement until 2013. What strategies ensured the success of the Voyager missions? One particularly brilliant technique was gravity assist maneuvers, a fundamental factor in their historic journey. The ingenious gravity assist maneuvers. One of the key strategies that ensured the success of the Voyager missions was the use of gravity assist maneuvers. This technique, also known as a slingshot maneuver, allowed the spacecraft to gain speed and adjust their trajectories by using the gravitational pull of planets they encountered. By precisely timing their flybys of Jupiter and Saturn, both Voyager 1 and Voyager 2 were able to harness the immense gravitational forces of these gas giants. This process effectively boosted their velocity without requiring additional fuel, enabling them to reach the outer planets and, ultimately, interstellar space. The Voyager's use of gravity assist was groundbreaking. It set a precedent for future deep space missions. Later spacecraft, such as Galileo, Cassini, and New Horizons, all relied on similar techniques to navigate the solar system efficiently. Entering interstellar space. On August 25, 2012, after traveling more than 18 billion kilometers, 11 billion miles, from Earth, Voyager 1 officially crossed the heliopause, the boundary where the Sun's influence weakens and interstellar space begins. This moment marked humanity's first venture into the interstellar medium, a vast region filled with cosmic radiation, charged particles, and material from ancient supernovae. NASA scientists confirmed this achievement after analyzing data from Voyager 1's Plasma Wave Science (PWS) instrument. Instead of detecting the charged particles from the sun's solar wind, the spacecraft encountered high-energy cosmic rays originating from deep space. Voyager 2 followed suit on November 5, 2018, becoming the second human-made object to leave the solar system. However, unlike its twin, Voyager 2's Plasma Science Experiment, PLS, was still operational, allowing scientists to directly measure the temperature and density of interstellar plasma for the first time. The mysterious signals from Voyager 1. Despite their astonishing longevity, the Voyager probes have recently begun transmitting puzzling data back to Earth, particularly Voyager 1, which has been sending strange, incomprehensible signals that have left NASA engineers baffled. In May 2022, mission controllers at NASA's Jet Propulsion Laboratory, JPL, reported that Voyager 1's Attitude Articulation and Control System, AACS, was sending corrupted telemetry data. The AACS is responsible for keeping the spacecraft's antenna pointed at Earth, ensuring smooth communication. However, instead of transmitting normal status updates, the data appeared random, distorted, or meaningless. Even more mysteriously, Voyager 1 continued to function normally, receiving commands from Earth and executing them correctly. This suggested that the spacecraft itself was not in danger, but rather that something had gone wrong with its ability to properly report its own status. Possible explanations. Scientists have proposed several theories to explain these bizarre transmissions. 1. A software glitch or memory corruption. One possibility is that Voyager 1's computer memory has been corrupted due to decades of exposure to cosmic radiation. If critical software instructions were altered, it could have caused the AACS to behave unpredictably. 2. Hardware degradation. After nearly 50 years in space, some of Voyager 1's hardware components may be failing due to age. Even though NASA has carefully managed the spacecraft's power and resources, its onboard systems were never designed to last this long. 3. A cosmic event. Some researchers speculate that Voyager may first have encountered an unexpected phenomenon in interstellar space, such as a strong magnetic field or an unknown type of cosmic radiation that disrupted its systems. 4. Extraterrestrial interference. While unlikely, some enthusiasts have even speculated that the strange signals could be a form of interference or response from an unknown extraterrestrial source. However, there is currently no scientific evidence to support this idea. NASA's response and the future of Voyager 1. Despite these challenges, NASA engineers have been carefully troubleshooting the issue, sending commands to the spacecraft and analyzing the responses. Since Voyager 1 is now more than 24 billion kilometers, 15 billion miles, away, it takes over 22 hours for a signal to reach it, making communication slow and complex. In late 2022, NASA managed to identify part of the issue. Voyager 1's AACS had started sending telemetry data through an incorrect computer system, which had been damaged long ago. Engineers sent a command instructing the AACS to use the correct system again, and the spacecraft partially resumed normal operation. However, some anomalies remain, and NASA is running out of power options. The radioisotope thermoelectric generators, RTGs, that power Voyager 1 and Voyager 2 are slowly losing their ability to generate electricity. To extend the mission, engineers have turned off non-essential instruments, prioritizing only the most crucial scientific functions. The legacy of the Voyager missions. Even as the Voyager probes approach the end of their operational lifetimes, their legacy remains unparalleled. These twin spacecraft have provided decades of groundbreaking discoveries, from the first close-up views of the outer planets to the first direct measurements of interstellar space. Perhaps most importantly, Voyager 1 and Voyager 2 each carry a golden record, a time capsule containing sounds, images, and greetings from Earth, intended for any intelligent extraterrestrial beings that might one day find them. The record includes music from various cultures, spoken greetings in 55 languages, and sounds from nature, such as whales, thunderstorms, and laughter. The final journey. As their power dwindles, the Voyager probes will gradually go silent. Scientists estimate that by 2030, the spacecraft will no longer be able to send data back to Earth. However, even after they stop transmitting, they will continue drifting through the cosmos for millions, if not billions, of years, carrying their precious messages from humanity into the unknown. If an alien civilization ever discovers one of these ancient spacecraft, they will find a snapshot of Earth, a record of who we were, where we came from, and our hopes of reaching beyond the stars. For now, Voyager 1 and Voyager 2 remain our far-flung ambassadors, venturing deeper into the cosmos than any human-made object in history. Yet again, pushing Voyager 1 and Voyager 2 on their brassy mission to investigate the external reach of our nearby planetary group, to arrive at these far-off destinations and gather significant data, the spacecraft required something other than their own propulsion systems. They required a boost, and gravity assists provided just that. Imagine the two courageous rockets, Voyager 1 and Voyager 2, setting out on their grand tour of the local planetary system. Rather than relying solely on their engines, they engaged in a celestial dance with some of our local planet's heavyweights. These planets formed groups that performed an extraordinary dance, using their massive gravitational pull to slingshot the spacecraft on their way. This technique allowed them to conserve valuable fuel and gain the necessary speed to visit multiple destinations. Delving into the basics of gravity assist, otherwise known as a gravitational slingshot, we see that the idea behind this maneuver is to transfer some of a planet's energy to the spacecraft as it passes by. Imagine Voyager 1 approaching Jupiter, a massive gas giant with an immense gravitational pull. With meticulous precision, Voyager 1 passed by Jupiter at the perfect angle and speed. Jupiter's gravity pulled at the spacecraft, accelerating it to a higher velocity and giving it a significant boost. Performing a gravity assist maneuver requires exceptional precision. If Voyager 1 had approached Jupiter at the wrong angle or speed, the slingshot could have resulted in a disastrous deviation from its intended course. The level of accuracy required is overwhelming. However, the brilliant minds behind these missions successfully executed these gravity assists multiple times, propelling the Voyager spacecraft on a breathtaking journey through the local planetary system. Voyager 2, for example, used gravity assists from Jupiter and Saturn to reach Uranus and Neptune. These celestial maneuvers were of fundamental importance in making the grand tour possible. The Voyager missions owe much of their success to these gravity assist maneuvers. Voyager 1 eventually reached interstellar space, with Voyager 2 following closely behind, all thanks to the precision of these maneuvers. The concept behind gravity assist is simple, yet its execution is incredibly complex. Voyager 2's grand tour required such a high level of precision that missing even one of these slingshots could have resulted in mission failure. However, the dedicated individuals behind these missions were determined and unwavering in their pursuit of knowledge. While gravity assists played a crucial role in space exploration, another critical component ensured the success of the Voyager missions, the Deep Space Network, DSN, often regarded as the interstellar telephone line that kept us connected to our brave explorer probes as they ventured into the great unknown. The DSN, though less visible than the spacecraft, is equally vital. The Deep Space Network is a system of massive radio antennas strategically placed worldwide, with locations in California, Spain, and Australia. These enormous dishes, ranging from 26 to an incredible 70 meters in diameter, act as powerful amplifiers, facilitating communication with spacecraft traveling beyond our planet. The Voyager probes, equipped with cameras, sensors, and instruments, served as our eyes and ears in the vastness of space. To interpret the data they sent and provide them with new instructions, a robust communication system was essential. That's where the DSN came into play. Imagine Voyager 1, en route to the outer reaches of the solar system, transmitting a message back to Earth, a faint signal traveling at the speed of light. As it crosses the immense void, the transmission weakens. By the time it reaches Earth, it is merely a whisper. However, the DSN's massive radio antennas are ready to capture that whisper. They lock onto Voyager's weak transmission, process it, and transform it into data that scientists can analyze. But the DSN doesn't just receive signals, it also sends commands. The Voyager missions are active undertakings, requiring scientists and engineers to adjust trajectories, redirect the spacecraft, or modify instruments. These commands are transmitted via the DSN, which sends them into space to reach Voyager and guide its journey. It functions as a two-way conversation between Earth and the farthest human-made objects in the universe. One remarkable aspect of the DSN is its unwavering operation. It works tirelessly, 24/7, listening for those distant signals. It is like an unblinking eye on the cosmos, ensuring that we remain connected to our space probes, even when they are billions of miles away. The Voyager mission stands as a testament to the power of teamwork and innovation. While the spacecraft embarked on their magnificent journeys, the DSN ensured they were never truly alone. It bridged the gap between our planet and the unknown, enabling us to explore the outer planets and venture into interstellar space. But did Voyager 1 experience a malfunction, or was something else, perhaps extraterrestrial involvement, at play? Throughout its extraordinary 45-year journey in space, the Voyager 1 probe has remained remarkably resilient, persistently carrying out its mission. However, in recent years, scientists have observed anomalies in its performance, sparking interest and speculation. Voyager 1 is currently transmitting unusual messages back to Earth, creating the impression that it is uncertain about its exact location. What makes this discovery even more puzzling is that the initial data received from Voyager 1 was unintelligible and indecipherable, leaving NASA scientists baffled. Upon investigation, researchers found that the culprit behind the distorted data was the Attitude Articulation and Control System, AACS. This onboard system is responsible for measuring, reporting, and adjusting the spacecraft's orientation in space. It has an antenna pointed toward Earth, allowing it to transmit data back home. The glitch occurred when the software unexpectedly switched to transmitting telemetry data through a faulty onboard computer that had been dormant for years. NASA engineers managed to resolve this anomaly by instructing the spacecraft to resume sending data through the correct computer, restoring uncorrupted transmissions from Voyager 1. However, the unanswered question remains: why did the spacecraft switch to the malfunctioning computer in the first place? While NASA scientists have hypothesized that a faulty command from another onboard computer could have triggered the strange behavior, they have yet to pinpoint the exact cause. To get to the bottom of this mystery, Susan Dodd, the project manager for the Voyager interstellar mission, stated that they plan to conduct a thorough memory readout of the spacecraft and analyze its operations in detail. This in-depth examination aims to uncover the root cause of the telemetry issue. It is crucial to note that, despite the erratic data transmission, the spacecraft itself appears to be functioning properly. None of the spacecraft's fault protection systems have been triggered. As such, Voyager 1 has not been forced into safe mode, and its transmission remains strong. A potential factor contributing to this inconsistency is the harsh environment of space. Cosmic radiation and extreme temperature fluctuations can present significant challenges to a spacecraft like Voyager 1. Cosmic radiation consists of high-energy particles originating from distant stars and galaxies. These particles can penetrate spacecraft structures, causing electrical disturbances, signal distortions, memory errors, and data corruption. Additionally, temperatures in the vastness of space can drop to freezing levels or soar to scorching highs, placing immense stress on the spacecraft's components. Despite the rigorous testing and meticulous engineering that went into designing Voyager 1 to withstand these conditions, the harsh realities of space can still take their toll over time. Another intriguing possibility that has captured some imaginations is the notion of extraterrestrial interference. Could Voyager 1's strange behavior be attributed to the actions of intelligent beings from beyond our solar system? While this idea may seem more like science fiction than reality, it is not entirely impossible. The vastness of space and the countless exoplanets it harbors leave room for speculation about civilizations far more advanced than our own. However, before jumping to conclusions about alien involvement, scientists are meticulously examining every aspect of Voyager 1's erratic behavior. Whether the spacecraft's anomaly is due to a technical glitch, cosmic radiation, or something entirely unforeseen remains to be seen. But one thing is certain: the mysteries of space continue to captivate and inspire us, driving our relentless pursuit of knowledge and understanding of the universe.